Hello, we are Team 4, made up of Valeria, Agustin, Julia, Santiago, Adrian, Harold, and me, Gwendolyn. Our project is called Photocells, and this goal is to provide energy and electricity to homeless and business. Business? We are talking the major problem of pollution from fuels like coal, oil, and natural gas. These fuels release harmful pollutant into the air, damaging the environment. Or invention provides energy without creating pollutants. Plus, the photosynthesis process of the microalgae helps to remove CO2 from the air. That's why we're focusing on SDG 7, a formidable and clean energy.
This is our prototype. It consists in a container which will have some water into it, and in the water we will have some algae. Down the water we will have an aluminum plate which will be the responsible of getting the energy produced by the algae. Our prototype is actually not working, but it can represent good how the actual project will work. Our prototype explains well how the project will work because it can simulate the form of the actual project. The actual project will have also some algae in the water, so it can produce its process of photosynthesis. Also, the container needs to be transparent because it needs to get the sunlight through, so it can produce the photosynthesis. But in the actual project, we will have a top on it, so it can get more part of the sunlight. And to produce, and while the project goes through, it can produce both. Can produce energy, which will be get by this aluminum plate, and it can produce also oxygen, which will be released from the top and with some holes in the top. The energy produced by the project will be connected to a battery, which will be collecting all the energy produced, which is not too much, but it can help a lot. Also taking care of the environment. The first one will be a coated glass layer that it's gonna receive the light from the sun. Then the light is going to be transmitted to the microalgae containers. So when the microalgae receives the light, they produce photosynthesis. Then the biomass produced by the photosynthesis will go to the copper electrode layer, which will process it and transport it, will convert it to energy basically, and will collect all the carbon dioxide. And then there will be a cardboard layer that will prevent some some possible fires. And finally, there will be some metallic edges on the whole system that will prevent the water of the microalgae containers to escape.
Hi, I'm Agustin, and I will explain the variables and measurements plans for our project. We're focusing on three main things: CO2 absorption, electricity generation, and algae growth. To measure CO2 absorption, we will use air sensors that compare the CO2 levels before and after they pass through the view panel. For electricity, we will use a multimeter to track how much power it produces, and for the algae growth, we will measure the water optical density with a light sensor, basically how much light passes through it. Each measurement has a purpose. CO2 absorption tells how effective our system is at reducing pollution. The electricity output shows the clean energy we can generate, and the area growth shows how sustainable the system is over time. A prototype helps by combining all these measurements in one unit, so we can monitor performance in real time and see how well it could work in real buildings. Thanks.
Hi, I'm going to be talking about the potential benefits that our project has. Well, mainly our project seeks to generate energy while benefiting the environment as a whole. And it is eco-friendly because the seaweed farming that we're planning to do helps reduce the levels of CO2 and produce the O2 with the photosynthesis process. It also forms and from an economic perspective, it is relatively cheap since the algae only needs water, CO2, nutrients, and sun rays to survive and produce energy. And furthermore, it also helps reduce the constant use of fossil fuels that so that it can make clean energy and it can make it more accessible to all of the public as a whole. By capturing the CO2 energy from the air, it also turns the urban infrastructure into part of the solution rather than part of the problem and add it to the pile of problems that we have right now. So then, if you're asking who can use our solution, well, the idea is that it can be implemented in buildings or on any facade. It is designated to generate energy and light in homes or establishments. And for optimal function, it is meant to be placed on the roof so that the sun rays give enough sunlight in the cells. How does our prototype enable measurement? And how does it connect to our measurement plan? Well, then, finally, our prototype mainly directly facilitates our measurements since the biomass produced by the algae is received by a copper electrolyzer, which then will process and transport energy as well as collect the CO2. As a team, we also believe that implementing our photocell can make clean energy and more accessible for families and businesses while actively cleaning our air, and it is a practical step towards a sustainable future as a whole. And in summary, I would like to add that our photocell offers a tangible path towards affordable clean energy and also direct air purification, and it also offers a new role for our buildings and environmental solutions and eco-friendly ones.
By using microalgae, we are able to take advantage of the natural process of photosynthesis to produce small amounts of electricity, release oxygen, and capture carbon dioxide around the atmosphere. Even though the efficiency is still much lower than that of traditional solar panels, this kind of technology has great economical potential because it not only generates energy but also improves air quality. Our project aims to inspire the development of sustainable solutions to combine biology and engineering, providing that even the simplest organisms can help us build a cleaner and more balanced future for our planet. Thanks.